Alright guys, welcome. We are going to talk about composite functions today. And so we are going to open our Advanced Algebra Notes and Homework Packet to this page right here. Okay, so when we open this page, we're going to notice that here is some explanations of composite functions. Now, what you've already learned is that when you have, for an example, a function f of x equals, say, 2x plus 1, and we say, okay, let's find out what f of 3 is. You plug that 3 into where the x is, so that then you know when x is 1, f of 3 would be 7. Oops, f of 3 is 7. Okay, so when x is 3, y is 7. Okay, so that is something that we've already talked about, that we've discussed, that we know. Now we're going to talk about something a little bit more in depth about functions. Now, one thing that you also need to keep in mind is that when we talk about the x value, this is your input. And we talk about your y value, these are your outputs. So just kind of keep that in mind as we're going through when x is being input into a function and then that function kind of manipulates it and then what comes out. Okay, so these composite functions, if you have, for an example, f of f plus x of x is the same as f of x plus g of x. When you have the product or multiplying f times g of x, it can also be written this way. F minus g of x is the same as f of x minus g of x. And the quotient, when you're dividing, it's just the same. So just kind of be familiar with that as we move on. Now, when we talk about the composition, if you notice this is a small little circle there. This just means f of g of x. So, and it can be written either way. These are synonymous. Moving on, given f of x equals the square root of x minus 5, g of x equals minus 3 over x, and h of x is 2x squared plus 3x minus 1, and k of x equals 4x minus 5. To find the domain of each one, well, we know that the domain of f of x, we do have a domain restriction because we remember domain is typically negative infinity to positive infinity unless you have a variable in the denominator or a variable as a radicand or in a square root. Okay, so f of x, we have it as a variable because we know that these always has to be positive, right? And we know that this cannot equal 0. So given f of x is the square root of x minus 5, I'm going to write that as f of x equals the square root of x minus 5. We know whatever's underneath here has to be positive. So x minus 5 has to be greater than or equal to 0. When I solve that, I'm going to add 5 to both sides and get x has to be greater than or equal to 5. Okay, so to write that, we're going to say our very lowest number is going to be 5. And it can equal it, so I'm going to put a bracket. And our very highest number can be infinity. Anything under 5 is going to create a negative radicand, so we cannot have that. So our domain, this is going to be our domain, okay, for f of x. What about g of x? Well, g of x, we see that we have x in the denominator. So when we have x in the denominator, we know that that denominator cannot equal 0. So how do I write that? X can be any number except when that denominator is equal to 0. Well, if I set the denominator equal to 0, I'm going to see that x equals 0, so that x cannot equal 0. So how do I write that? I just say negative infinity to 0 and parentheses 0 to positive infinity. This is telling me that basically x can be any number except for 0. You see how that excludes 0 from the domain. The next is going to be h of x equals 2x squared plus 3x minus 1. Do we have any of our restrictions? Do we have a situation where an unknown is in the denominator? No. Do we have a situation where an unknown is in a square root? No. So my domain here is going to be negative infinity to positive infinity. And then what about k of x? Again, 4x minus 5. Do I have a situation where I have a variable in the denominator? No. Do I have a situation where the variable is in the square root? No. So my domain is going to be negative infinity to positive infinity. Alright, so now we've got our 4 domains. What about when we do this? This is telling us the function of h plus the function of k. So we can basically rewrite this as h of x plus k of x, if you want to write it that way. Those are the same. It shows us right up here. These are synonymous. So to work that out, I'm going to say, all right, h of x is 2x squared plus 3x minus 1. That's my h of x, plus k of x, which is 4x minus 5. So I'm just going to simplify this. That's this. And I'm just going to create my like terms, or combine my like terms. My x squared has no like terms. 3x plus 4x is 7x. Negative 1 minus 5 is negative 6. Alright, what about this? Now we're multiplying these, okay? So I'm going to take this is the same as h of x times k of x. Right? This shows right up here. I'm just multiplying them. It's just really kind of learning vocabulary and then doing what they're telling you to do. So my h of x is 2x squared plus 3x minus 1 times 4x minus 5. Now, keep in mind, we're multiplying polynomials, so you must FOIL these. You have to make sure that you distribute this 4x to every term and that you distribute the 5 to every term. Okay, so to do that, when I start out with 4x times 2x squared, I'm going to get 8x cubed. 4x times 3x is going to give me 12x squared. And leave a space. 4x minus 1 is going to give me minus 4x. Then negative 5 times 2x squared is going to give me minus 10x squared. Negative 5 times 3x is going to give me negative 15x. Negative 5 times negative 1 is going to give me positive 5. So when I combine all my like terms, I'm going to end up with 8x cubed minus 2x squared minus 19x plus 5. So there's your two functions multiplied together. Next, we are adding these. So we're going to just take f of x, which is the same as f of x plus g of x. So my f of x is the square root of x minus 5 plus negative 3 over x. Well, there's lots of different ways you can leave it like that, or if you want to create a common denominator, this would be x minus 5 plus 3 all over x. So that's basically as much as you can simplify that, or this. Either one of those are correct. Here we've got f of x minus g of x, so we've got the square root of x minus 5 minus a negative 3 over x. And I noticed that I lost my negative over here, so this should actually be minus. And because over here it's going to turn positive. So when I work this out, I'm going to get x minus 5, if I want a common denominator, plus 3 over x. And then that would just give me all over x. Okay. You're just using the same math skills as you guys are familiar with. I know you don't like fractions, but you use the same math skills as you know, and you just go through the motions. All right, f of x, or f times g of x, is the same as f of x times g of x. So we're going to take the square root of x minus 5 times negative 3 over x. And again, you just multiply it, so that's just going to be negative 3 over x, x minus 5. You can't simplify any of this anymore. And then this last one is just going to be f of x divided by g of x. So we take the square root of x minus 5 divided by negative 3 over x. Now here, I need to, that is the same thing as, sorry about that, people, times x over negative 3. So then that is going to equal x minus 5 over 3, and that would be negative. Alright, you're just multiplying your numerators, and you've got your denominator. Okay, so we're just really showing that how to manipulate those functions. We haven't really done anything other than just putting them side by side and working those math problems. So go ahead, and this is actually a really important thing that you need to do on your own. So pause the video and work this out, and I'll show you what you're doing. You're basically just plugging in whatever is in these parentheses in for the x. So here x is in both places, blank is in both places. So the first one would be, I've got a 2 here. I put a 2 where the x was. Go ahead and pause the video and do the rest, because that is a good practice to do. So hopefully this is what you got. Please make sure that you're able to do this. This is really the crux of this whole stuff. Once you're able to start doing this more mechanically and not think about it, then it's going to make your life a lot easier. So if we've got g of x equals x plus 2, find f of g of x. So what you do is you start with your f of x. You start with your f function, because that's the first one. And you write that for, and instead of x, I'm just going to put parentheses minus 1. Then what goes inside of here is your g of x function. Well, my g of x function is x plus 2, so I'm just going to put 2x, or x plus 2 there. Now I'm just going to solve this, or at least simplify it. I'm not solving anything because there's no equal sign. 4x plus 8 minus 1, that's going to give me 4x plus 7. So simplified, f of g of x would be 4x plus 7. Okay? You're just putting one function in for the other. Alright? So here this is the same thing. This f of g of x can be written as f of g of x. I'm not sure which one you prefer. It doesn't matter because they both mean the same thing. So we're going to take, f comes first, so I'm going to take this function and I'm going to write it out, but instead of my x, I'm going to just put parentheses squared minus 9. Then what's going to go inside those parentheses is my g of x function. So this part. So this is going to be the square root of 9 minus x squared. Now, when I square the square root, hopefully you know that when I multiply this, the square root of 9 minus x squared times the square root of 9 minus x squared should equal 9 minus x squared. Hopefully you know that. If you don't, well, there you go. So I'm going to get 9 minus x squared minus 9. 9 minus 9 is 0, so I get negative x squared. Alright, so the composition of f of g of x is negative x squared. What is the domain of the composition? Well, if I'm looking just at this, I would say all real numbers. But you have to keep in mind that it had to go through this first. It could never have gotten here had it not gone through this first. So you have to actually think of the domain of everything that it goes through. So my domain here is all real numbers. My domain here is that 9 minus x squared has to be greater than or equal to 0. So when I solve that, I get and that's where, here's where it gets a little tricky. So I'm going to divide both sides by a negative. So I'm going to flip my sign because I'm dividing by a negative. So I have to flip my inequality sign. But now at this point, since I have a square, I have to create two equations. So when I take the square root of both sides, I have to create two different equations. X is less than or equal to the square root of 9. But then you also have to create x is greater than or equal to the negative square root of 9. And that's because x squared can be either a positive or a negative, because a negative times a negative is going to give you a positive. So here's where it starts to get kind of fun. You have to remember, so you create one equation that looks just like this, except for you've taken the square root of both sides. The second equation is going to look like the opposite. So when I solve this, I get x is less than or equal to 3. And this one, I'm going to get x is greater than or equal to negative 3. Okay? And here you can see that, and I'll just show you. On here, you can see I've graphed it on Desmos, and you can see it goes from negative 3 to positive 3. Here is my function. And you can see the domain. The lowest is negative 3. The highest is positive 3. So that's one way you can kind of also check your answers. Okay? So, moving on, we've got example number 3. We've got f of x equals x plus 3. Now we're kind of looking into this. If I've got f of x plus h, I'm basically going to take that x and put x plus h in there. So x plus h plus 3 minus, and then f of x, which I'm going to put parentheses around there, and I'm going to tell you the reason I'm doing that is because I know I'm going to need to distribute that negative. Please be very careful about that. All over h. So this is what you should get there. Pause and make sure you understand how to do that. Now I'm going to just combine my like terms, and I'm going to distribute that negative sign so that then when x minus x is 0, 3 minus 3 is 0, I'm left with h over h, which is 1. Alright, this, again, pause the video and see if you can figure out how to work this. This is g of f of x, which means you're going to start with the g and plug everywhere there's an x, you're going to plug in this x plus 3. So if my base is g, pause and you do it. My base is g, I'm going to have whatever squared minus 2 of whatever minus 15. So then in here I'm plugging in x plus 3, x plus 3, and now I'm working it out. This is g of f of x. So now when I work this out, I'm going to FOIL this. Make sure you FOIL it. So I get x squared plus 6x plus 9 minus, I'm going to distribute this, 2x minus 6 minus 15. Now I just combine my like terms and get x squared plus 4x and then minus 12. Alright. And moving on to the very last one, we're not going to do example 5, so this is the last one. Keep in mind when you're doing f of 1, all you're doing is finding where is x1. Well, x is negative 2 there, x is negative 1 here, x is 0 here, x is 1 here. So f of 1 equals negative 1. When x is 1, y is negative 1. It's that easy. Don't overthink these. Find g of negative 1. Well, I'm going to look at g now. I'm looking at my x values where x is negative 1 in my g function. And I'm looking and I see it's negative 2. But here it's saying find g of f of 1. And so what you do for these is you're saying, all right, f of 1 is negative 1. So then you come over here and say, I found f of 1 is negative 1, so then what is g of negative 1? Well, g of negative 1 equals negative 2. So pause the video and see if you could figure out if you were given this problem. What is f of g of 0? Okay, pause it now. So you should have found that f of g of 0 is 2, right? When g is 0, when x is 0 in the g function, you get 2. And when you use that as your x, you come up here and you find that 2, negative 3. So there you go. That's it for today. Your homework is page 506. 4 through 52 and multiples of 4.